On this frictionless surface, we have two blocks, a 2 kilogram and a 7 kilogram block. This time, they are traveling in opposite directions with speeds of 10 meters per second and 4 meters per second. The blocks collide elastically again, and we want to find the velocities of the two blocks immediately after the collision. Again, we're going to use the approaching speed equals to the separating speed to help us to reduce the number of unknowns from 2 to 1. The approaching speed is the difference in velocities. And what do we have to pay attention to at this time? We have to pay attention to the direction. If I say this velocity is a positive 10, then this opposite direction velocity has to be negative 4. So the velocity difference is 10 minus negative 4, which is 14 meters per second. Another way to look at this is the two blocks, they get closer and closer every second by 10 meters per second from the 2 kilogram and 4 meters per second from the 7 kilograms. So if you add 10 to 4 every second, they get 14 meters closer. And this is the separating speed, which means if v1f is the velocity of the 2 kilogram at the end, the one in the front must have a velocity that is v1f plus 14, because the one in the front has to be 14 faster, or more accurately, 14 more positive in velocities than the block in the back. So now we have only one unknown. That means we need to write one equation. And what is that equation we should write? We should write it's better to write the momentum conservation. It's going to be easier than the kinetic energy conservation. So let's see. Initially, the two blocks have momentum, mass times the velocity, plus the mass times the velocity, which is negative 4. And afterwards, we have mass 2 kilogram times velocity v1f plus 7 kilogram times velocity v1f plus 14. So this gives me 20 minus 28, which is negative 8, equals to 2v1f plus 7v1f. That's 9v1f. And I have to remember to multiply the 7 by 14, and I get 98. So if I subtract 98 on both sides, I'm going to get negative 106, and that equals to 9 times the v1f. So I will get v1f is negative 11.8 meters per second. It's a negative velocity, so it is to the left. And then the v2f would be v1f plus 14. So it's negative 11.8 plus 14. And this gives me 2.2 meters per second. And it's a positive velocity, so this one goes to the right. So this one is 11.8 meters per second to the left, and this one is 2.2 to the right. So over here, the block in the back is faster than the block in the front, but in terms of speed, it is only 6 meters per second faster. So what we really mean is the velocity is 14 more positive than that one. And afterwards, the same thing. See, the block in the front is not really faster, but it does have a more positive velocity, and it's more positive than this velocity by 14.